Hello everyone and welcome to the next lecture in our data structure algorithm series. I am Dr. Mangesh Joshi from Department of Mechanical Engineering. Today we will learn about insertion sort, a simple yet powerful sorting algorithm that works well for small datasets. It is commonly compared to how we sort playing cards by hand. So without wasting time, let's start with insertion sort. So what is insertion sort? So insertion sort is a comparison based sorting algorithm that builds the sorted list one element at a time by repeatedly picking the next item and inserting it into correct position. A helpful way to visualize this is by thinking about sorting playing cards in your hand. Take one card at a time and insert it at the right position among already sorted ones. This is also done by many subject teachers or invigilators once they collected all the answer sheets from the students. They basically sort with this insertion sort only. They start with first answer sheet, then they see second answer sheet, whether roll number written on it is lesser or greater. If it is greater, they put it at the back. And they do same for all the answer sheets, right? So that is basically the insertion sort. This is for example roll number 1. Then suppose comes next answer sheet roll number 10. So this will be put at the back. Then next answer sheet suppose roll number 7. So it will be put between 1 and 10 likewise. In this way the insertion sort works. Let us understand step-by-step explanation about how insertion sort works. So start from the second element, that is index 1, assuming the first element is already sorted. I just explained this, that you have to assume that first element is already sorted. Then compare the current element with those before it, right? Shift all larger elements to the right. So if you arrange answer sheets in this fashion, so if it is greater, you put it on the right. Insert the current element into correct position. Repeat the process for all elements. I have just demonstrated these steps with this example. Let us understand this with a suitable example, that is initial array having 7, 12, 9, 11, 3 elements. So first element is considered sorted. So we will not do anything with 7. We will start with 12. Now next we will compare 12 with 7. As 12 is greater than 7, no changes there. Then partition line is here, means now this is the sorted part, this is unsorted part. Next we pick up 9, right? Because next element was 9. So then we compare 9 with 12, right? So since 9 will be inserted in between these two, so compare 9 with 12, shift 12 as 9 is lesser. Now compare 9 with 7. So 9 is greater than 7, so it will be inserted after 7, right? So result will be 7, 9, 12, 11, 3. Now this is the sorted part, this is unsorted part. Now compare 11 with 12. As 11 is lesser than 12, shift 12 here, shift 11 here. Now compare 11 with 9. So 9 is lesser, so no change, and hence we will insert 11 after 9. So 11 will be inserted over here, right? So after that only remains 3. So next stage is compare 3 with 12. Now since it is less than 12, we will insert it over here. Then we will compare 3 with 11. Again it is smaller than 11. Next we will compare 3 with 9. Again it is smaller, and finally this will go to step number or index number 0 at the beginning. So finally you get the sorted array in this form: 3, 7, 9, 11 and 12. In this way it works, insertion sort. So to implement insertion sort in programming language, we need an array containing the elements to be sorted, a loop to iterate through each element in the array, a shifting mechanism to move larger elements to the right, logic to insert current element into its correct position within the sorted part. And finally, this is typically done iteratively for simplicity, not recursively. Means the same function will not call it itself. It is to be done on iterative basis. This is the logic given, that is a function for insertion sort. Let us understand this code step by step. So this statement defines a function called insertion sort. It takes an array as input and its size also as input. So the array will be sorted in place, meaning no additional or temporary array is required. Then a for loop starts from the second element. You can see I is equals to 1 is there, that is starting from second element, because we assume the first element is already sorted. Now loops through each element one by one, right? Then next is integer key, ARR of I. So the element at index I is stored in key. This is the element we want to insert into correct position in the sorted part of the array. So first element is assigned to key variable. Then next part of the code is int j equals to I minus 1. So start comparing with the element just before the key. Means as we have explained it here, in this case we need to check just before the key. So that's why it is done I minus 1. So while loop runs as long as j is within array bounds, that is j is greater than 0 and error of j is greater than key element, right? So inside the loop, shift error of j one position to the right, since it is j plus 1. So if this is 3 and so this is 4 basically, so 3 will be shifted on the right side, right? And j minus minus will do next element to the left. And finally update the value of key element to at next position. That's why error of j plus 1. This is the basic logic of insertion sort. Coming to pros and cons. So it is simple to implement, efficient for small data sets. It is a stable sort, means equal elements retain their order. So in place sorting takes place, hence no extra space is required for storing arrays or variables. Coming to cons, inefficient for large lists. So the time complexity is n square in worst case. And again, same, it is not suitable for large data sets. So if we take to understand this, if you take example of just say sorting 1,000 papers by invigilator, you can just imagine how much time it will require by sorting it manually, right? So that's why it is inefficient. That brings us to the end of our lecture on insertion sort. So it's a simple intuitive algorithm that is great for small list and educational purposes only. In the next lecture, we will move on to more efficient algorithms like merge sort. Thank you for watching this video lecture, and as always, feel free to ask any questions. See you next time. Have a nice day.